Hello, so this is on Poly, which is a resilience library for .NET. So it gives you a nice way of handling transient faults in your application. It's a good stable library to use. It's been around quite a few years. It's a member project of the .NET Foundation. Oh, we're back on. So a few terms. So you could say a fault is some undesired condition in your system. Whereas a failure is the inability of a system to function. And so Poly helps with resilience, which is the capacity of a system to handle faults without failing. And in Poly, you do this by creating error handling policies. So first of all, you define, you say what error cases you want to handle. So that can be an exception or bad return values. And then you say what you want to do in these error situations. So the easiest one is to try again, so retry or wait a bit and retry. You can also fall back to a known good value, or a bit more advanced as a circuit breaker, where you can you monitor the fault levels in a system, and then above a threshold you start failing fast and predictably, so you give the system time to recover before hitting it again. There's also some proactive policies, so these are ones where you're not waiting for a fault to occur. And these include, the simplest one's a timeout policy. So this is, you give it a time limit, and after that it'll just cancel the thing you're trying to run or kill it and move on. There's a bulkhead isolation one, which is so you can limit the concurrency in a certain bit of your system, and then if that starts failing, it's kind of isolated and it can't back up to your entire system. Another one is a cache policy. So don't make a call if you don't have to do. So if you have a good value already, use that. If you don't make the call, it can't fail. So this is kind of Poly on one slide. So first thing you've got to do is define one of these policies. So here I'm defining a simple retry policy. I'm saying I want to handle very bad exceptions being thrown. And I want to do that, handle these by retrying 2 times. And then I can take that policy and I can execute some code protected by that policy. So I can call policy.execute, and here I'm calling a local add method. And you wouldn't really use Poly to protect a local add method because it shouldn't transiently fail. This is just to show, as a quick example. So we run our add method, hopefully we get a result back. But if it does throw a very bad exception, then Poly will retry it and retry it again. If it still fails at that point, then the exception just gets thrown. A few things to mention. So these policies, you can reuse them. So you can define some error handling logic once, and then you can reuse it throughout your application. The other thing to point out is that Poly, it's very nice and readable, this code. So defining a policy is nice that you've got this fluent API style. It's easy to see how you're building a policy up. And then also running it kind of it's quite clear to see what's going on. The error handling logic doesn't take over. You can see your business logic quite well. So if you wanted to do a similar thing without using Poly, you'd write something like this. So you've got some sort of retry loop, and if add succeeds, you break out. Otherwise, you keep looping around until the retry count is reached. So this is fine, but you don't want to have to repeat this sort of code everywhere, especially if it gets more complicated. And also the bad thing here is that you've got way more error handling code than you do actual business logic, so it gets in the way a bit. So onto a demo. This is the demo of the Tesla Cybertruck of the unbreakable glass, which didn't work. My demo's less exciting. So don't read all of this, but I'm just going to show a few different policies and then how to combine them together. So here I'm making a timeout policy. So I'm saying if something takes longer than 8 seconds, then just move on, don't wait for it. And I'm using a pessimistic strategy, which means that I'm not using cancellation tokens. I'm just going to move on after the 8 seconds. I'm also making a retry policy. So here I want to handle very bad exceptions being thrown, and I want to wait and retry. So this is adding some wait in there after every retry. So retry up to 5 times, and I'm using a function to say to calculate how long to wait, and this is an exponential backoff thing, so it waits longer every time. I'm also using an overload where you can pass an action in there, so this is just going to log when this retry policy kicks in. Then I've got a couple of fallback policies, so this fallback policy will handle very bad exceptions, and it'll fall back to a value of -1. And this second one handles these timeout rejected exceptions, so this is thrown by poly if the timeout policy kicks in. And in that case, we'll fall back to a value of -2. So we've got all these policies, and then I can combine them together using this policy wrap. So I feed in all these policies and get one combined policy out. And the order is important here, so the rightmost or innermost policy is the one that gets first chance to handle any faults, and then it gets passed back along the chain. So we've got our combined policy, and then I can execute some code inside that. So I'm going to run my add method, and hopefully we'll get a result out. Unfortunately, my add method always throws a very bad exception. So let's run this. And you'll see, so the retry policy is kicking in because we're getting this exception thrown. It's taking longer every time. And then the very bad exception was rethrown because it still occurred. And our fallback policy kicked in, and we got a -1 result out. Now I can provoke the other path. So if I add some sleep into this add method and run again, so you'll see that the retry policy should have a go, but it's taking longer this time. And so our timeout policy kicked in, so it took longer than 8 seconds or whatever it was. And this time our other fallback policy caught this timeout rejected exception, and we fell back to a -2 value. So that's just a quick tour of the Poly API. So yeah, there'd be no point using this to protect a local add method, because it shouldn't transiently fail, and if it did, you'd have bigger problems. So transient faults are common in distributed systems, and this is where Poly comes in. So cloud services might go down due to network issues and throttling and scaling, that sort of thing. And we all write systems like this nowadays. So if one of these little microservices goes down, you don't want it to hose your entire system. So this is where Poly comes in handy. And I expect the most used type of fault handling in Poly is HTTP faults. So it's kind of up to you what you class as a transient HTTP fault and what makes sense for the system you're calling. Some examples of faults that might be transient are network failures, where you get an HTTP request exception. Also, a bunch of HTTP response status codes, the error codes, so 500s, which are server errors, 408s are request timeouts, and 429s are a throttling response. But it's up to you what makes sense in your system. Poly, inbuilt into Poly, there's a handle transient HTTP error method, which will start you off building a policy that handles these green ones. But then you can take that as a starting point and customize it and add in extra handlers as well. I'll show that in a minute. The other thing to point out is that you should consider idempotency when you're using this. So just because you can retry something 5 times, does that always make sense? So should you retry puts and posts or just get? And it depends on the system you're calling and how that behaves. So another demo. They tried it on the back window and that smashed as well, so that's not great. So this is going to be a demo on how to use Poly in ASP core. And down here, so I've got a simple web application, ASP core web app, and this calls a web service, which is a calculator service to add 2 numbers together. And my calculator web service isn't very good, and it fails exactly 2 times out of every 3 times you call it. And so I want to use Poly to add some resilience into calling this dodgy web service. So let's look at the code. So I'll show you as it is now without Poly. I've got a calculator page model, and I inject into the constructor an HTTP client factory. And then when the page is loaded, I get a named HTTP client from the factory, and I call my calculator web service using that and display the result. And in my startup class, I just configure this named HTTP client, give it a name, so I'm calling it calculator service, and all I'm doing is setting the base address of the calculator web service. So this is all standard ASP core stuff, and there's no resilience so far. So I'll now add in a poly policy, and you can actually do this without changing the calculator page model at all. So we can just do it by changing the startup class. So in this second version of startup, you'll see here now I'm making a retry policy, and I'm saying I want to handle HTTP request exceptions being thrown, or any result where the response is, let's get rid of that, where it's not a success status code, and handle those by waiting and retrying 3 times. And then the good bit here is when I'm making my I'm configuring my named HTTP client, I can use this extension method, add policy handler, to associate this retry policy with this client. So this means that any time you use this named client anywhere in your application, this policy will be in effect. I'll show you this working, but I'll show you a slightly more complicated version. So this is another version of startup, and in this one, I'm using Poly's inbuilt handle transient HTTP error to configure it for the basics, and then I'm customizing this bit by saying I also want to treat 429s as transient, and I'm still doing the wait and retry 3 times. And the other change here is when I add my policy handler, instead of just passing in the retry policy, this time I'm using an overload where I get to look at the request message, and I'm filtering it so that my retry policy will only apply on GET requests, and on any other type of request it will use a no-op policy, which is just null effect, it doesn't do anything. So let's change over to using this. Run it again. So hopefully this time when we hit the calculator page, it takes a bit longer, but we should always get a result. Slightly rigged because I know it's going to work 1 in 3 times. So there you go. That's a Poly in action. And that's it, I think. Yeah. So yeah, just to summarise, so Poly adds resilience to transient faults. I'd say start simple, just go for retries and timeouts and fallbacks. They're the best thing to use. You can look at circuit breakers and the more advanced things later, but don't start with those. And it's using Poly is certainly easier than rolling your own fault handling, and it keeps your code nice and readable, and yeah, it hooks in very nicely with ASP core. So that's it. Thank you.